Welcome everyone. In this video I'm going to show you some basic things regarding proximity sensors. So we have a capacitive proximity sensor here, and this is a very simple but quite useful sensor if you want to switch something without any kind of mechanical contacts. So this is why it is a proximity sensor. So how it works is that the sensing side or the sensor side is this blue cap, and then you have to approach some sort of surface, so for example the palm of my hand. So if you go closer, and for this specific sensor you have to go between 1 to 10 millimeters, then you turn on the output of this or turn it off depending on whether it is an NPN or PNP device. And then you can switch anything. And the very useful thing is that you can connect this thing to a microcontroller and then check its status with a microcontroller, whether by polling it or using it as an interrupt. And then you can do something. And as you can see in my setup, I have a stepper motor here. So I will just rotate this stepper motor in a certain direction, and then I trigger the proximity sensor and change the direction. So it's a very simple demonstration, but if you understand these principles, you can build a very powerful system by extending this thing. So once again, we have this proximity sensor. It's a relatively a small device. And then all we have is basically 3 wires on the other side. So we have a blue wire, which can be read here. It is the ground connection. And then we have a brown wire, which is the power supply connection, which should be between 6 to 36 volt DC. And then the black wire is the output. And then there are some other details here. What is the most important for us is that this is an NPN type of detector or sensor. So it means that when it detects the proximity of an object or a surface, then the output is connected to the negative power supply. So in fact it just goes to the ground. And this can be shown easily if I just put this into a circuit and just measure the output. And when I use this with the microcontroller and the stepper motor, then basically we just read the output pins or output pin with the microcontroller, and then based on the condition or status of that pin, whether it is high or low, then we do something in the code. And there is one thing that we have to be cautious about, is that this sensor replicates the input voltage on the output. So if you put 36 volts on this device, which is the maximum allowed input voltage, then the output voltage will be also at 36 volts. And that's probably not a good idea to be connected to the microcontroller, because you should not put anything higher than 5 volts on the I/O pins. So I did a very simple, maybe not the best solution here, but it's very simple. So I use a high resistance potentiometer, 100 kilo ohm potentiometer here. So I connect the positive side of the potentiometer to the output, and then the negative side of the potentiometer is on the ground. And the Viper, or the output of the potentiometer, is then connected to one of the I/O pins on the microcontroller. All you have to do before connecting the potentiometer to the microcontroller is that you decide what is your input voltage on the proximity sensor, and then adjust the output voltage of the potentiometer and put it somewhere between 3.35 volts. So that will be regarded as a high value when it is read by an I/O pin. And then just connect everything. And it's a very good thing that this runs at 36 volts, because it makes it very nicely compatible with stepper motor drivers, because these are also, let's say, operated in between 12 to 24 volts. So in fact, you can use the same power supply for your proximity sensor that you are using for your stepper motor or stepper motor driver. So I don't do that now because it's just extra wiring, but in principle you can use the same. And then when you plug everything together without connecting the output of the potentiometer to the microcontroller, then you just adjust the potentiometer in order to get the voltage, the output voltage in between 5 and 3 volts. And then when that's done, you just put in the missing wire, so connect the output of the potentiometer to one of the I/O pins that you just assign in your code, and that's all. So I will break this down to small details and try to show you how it works. So we will need a multimeter here, first of all, and then I just connect everything to the breadboard. So as we said, the brown goes to the positive power supply, so that is just connected here. And obviously, if you will check my website in the description, then you will see all the drawings and everything. But I also explain everything. So brown is the positive input, the black is the output, and then the blue is the ground or the negative side. So this is connected, and I just grab my power supply and I just show you that the input voltage will be 12 volts on this proximity sensor. So let me arrange the clips. So now what I'm doing, I'm measuring the voltage between the ground and then the output voltage directly on the output of the proximity sensor. So I just show you that it works. And I haven't connected anything to the microcontroller. So now, as you can see, this is now nowhere near a surface, and the output voltage of the proximity sensor is at the power supply voltage, so 12 volts. But then let me put it like this. So now I try to rotate it properly. So you see that the LED is on. We are close to some surface, pretty much close, and then the output of the proximity sensor is at the ground. As I said, this is an NPN device, so when there is a surface detected, then the output is connected to the negative power supply, which happens to be the ground here. So then I remove it, and the voltage should go back to 12 volts. So now I will try to show you the range of this thing. So we will have some kind of surface which is very visible, and I will just try to go closer and closer, and then you will see when it detects. So you see that this is like 5 millimeters, and then it turns off the output. And then if you really want to adjust this thing, then you have to use a screwdriver and turn this screw. So now I try to rotate in some certain direction. Now I'm turning it on clockwise direction, if you look at this thing in this way, and see how it changes. Obviously we can measure this with a ruler or something, but you can see that now I really messed up everything because it's already on the ground. So I can turn it in the other direction and see what is happening. So now I managed to find the point. So if I start to turn, you see, now it goes to ground. So I guess this will be the maximum range, the 1 centimeter. Yes. So when you turn this screw and you find the boundary between switching on the LED or switching off the LED by turning the screw, that is the upper limit of the range. So then you find when it turns on the LED without any kind of objects in front of it, and you start to turn it counterclockwise until the LED turns entirely off. So now you see that it doesn't detect any surface, but then you you can start to detect surfaces from quite a large distance. This is like, I don't know, 3 centimeters. We can actually check it. So here is a metal ruler, and then I can't really see it from the same angle, but from my angle, this is roughly 3.5 centimeters when it starts to get triggered, but maybe from the camera's angle it's a bit less. So you can see, and now if I keep this screw rotating counterclockwise, then I decrease the trigger distance. So I just did a few turns. And you see I have to go really close now, just a few millimeters in order to trigger the sensor. So this is fine. And now we go to the next step. So we adjust the output voltage of the potentiometer. So what happens is that now I connect the output of the proximity sensor to one side of the potentiometer, and then I measure the output of the potentiometer, and I adjust it in a way that when there is no object in front of the sensor, then the output voltage should be roughly 5 volts. And when there is something there, then it's obviously 0. And of course I tested this before recording everything, so now it's adjusted there. But so what you have to do basically is that you put your output wire on one of the inputs of the potentiometer, and then you just measure the output, the Viper of the potentiometer, and then you adjust it until you get 5 volts. So you see that if I start to turn it, I actually almost get back the power supply voltage, which is 12 volts. But then I start to rotate it in the other direction, and I get something like 5 volts, and then I can obviously go down to ground. But let's bring it back to something 5-ish. This is fine, actually, because this will already trigger the switch in the microcontroller. So now this goes ground, and this is high. So let's keep it high. And then I add another piece of wire, which should go to my microcontroller. So then the output voltage of the potentiometer is connected to one of the I/O pins, which is the PB10 in this case. So now we can follow the status. So let's go for the controlling electronics and see what is what. So here I would like to address a question for one of my viewers who has troubles with the STM32 connected to a DRV8825 stepper motor controller, which is here. So as you will see, and I hope you watch this video, it works. And it works in my previous video as well, you can check it there. So there is nothing fancy about it. All microcontrollers just have to output a step and a direction signal, and that's all. And I also have another video where I showed that was with an Arduino, but it doesn't change the fact that you can change the stepper motor driver to any kind of stepper motor driver as long as they have an input for direction and step. And this is roughly applies on all of these kind of drivers, because this is more or less some kind of standard that you have to provide a direction and a step signal, and then you can control your stepper motor. So you will see this thing in action, and I hope it will convince you that it works. So what I will do, I just connect the STM32 to a power supply, which is just a USB cable, and then also another 12 volt power supply goes for this driver. So you can see the lights blinking, and we had another switch, and this might jump here and there. So now I set the micro stepping to a very high stepping rate or division, so the motor goes very slowly, but you can see that now it goes counterclockwise, and this thing is triggered now, so it's close to some object because now it's on ground. But if I flip this, so it's not sensing, our output went high, and this turned the other way, and now it's clockwise. So you can see this is like crazy simple. If I can actually fix this. So now I again triggered the proximity sensor, goes counterclockwise. I removed it, so the surface is exposed, nothing is close to this, and then it goes clockwise. And you can do this very quickly. In fact, I will change this micro stepping to speed up the motor. So now it has some considerable speed, and you can see that it acts very quickly. And I will show you the code, but the code is really just 4 lines. So we are rotating the motor in one direction, and we always pull the output here. So it's not the most efficient code, but it works. So we are pulling the output of the proximity sensor, and we decide whether we should go clockwise or counterclockwise. And this is what happens here. It's extremely simple. So whenever I pull the output to the ground, we go counterclockwise. Whenever it is high, it goes clockwise. And you can see that this changes very quickly, so it reacts immediately. And here comes one of the options that you can use this as a end stop or limit switch. So yeah, you can use this as a limit switch, for example, and you can use it as a switch if you want to have something which is not a mechanical switch, but I think this is like extremely expensive to be used as some kind of button, so I would not use it for that. But for example, stopping a carriage, stopping a belt, or stopping something which is moving, this is very good. And you see that it changes everything immediately, of course, just some simple electronics. So it can be used very nicely. And now, as I showed you that this thing works, I will go to my computer and very quickly show you the code. But don't expect any kind of fancy code, because I will just show you the code behind this demonstration, but I will try to tell you how to modify it in order to make this into a more complex system. For example, using 2 of this or multiple of this, not even 2, but maybe 4, and so on and so on. So let's go to my computer and see what is on the microcontroller. So this is the code here, and it is very simple, so we will finish this quickly. So since we are using a stepper motor, we are using our favorite library, the Excel stepper library. And in this case, I defined the pins to be the PA9 and PA8. So the 9 is for the steps or pulses, and the 8 is for the direction. And then I also use the enable pin, and that is the PB12. So you can enable or disable the current through the coil or coils of the motor. And that's nice because you can prevent the motor to warm up too much. And then we have a pin for the proximity sensor, so I'm using the PB10. And I cannot stress enough that if you want to use the exact same code on an Arduino, then you have to define the pins in a different way, because here on STM32 that I'm using in this demonstration, we have several ports A, B, C, and therefore you have to tell the compiler that you are using this or that port. And the way that you tell is that you say PA9 instead of just typing in 9. So if you are using an Arduino, like Arduino Uno or Nano or Mega, and so on and so on, you just remove these but also you have to know which kind of pins you want to use. But this kind of definition for the pins is used for STM32. So we are done with this, and yeah, this was just some text in the setup just to see if everything works, but it's not necessary. And then we have our default values, let's say, for the stepper motor speed and acceleration. And then we have to define the stepper enable pin as an output, because we will switch it on and off, or set it to high or low based on what we want. And since we want to enable the current, because we want to move the motor, we will pull it down to low. So we just use this line, digital write line. And if you set this to high, then obviously the stepper driver will be disabled. So whatever you are trying to do, it will not run the motor. And yeah, I wrote a few sentences here, but you have to keep in mind that if you are like switching your motor on and off between movements, you can lose a few steps, because sometimes you need to hold the motor at a certain position, or the shaft of the motor at a certain position, and you have to continue from there. So you have to keep the motor at some certain current, or you have to keep it powered. So it's not really suggested to turn it on and off, but if you know that you move from one end of the shaft, for example, to another end of the shaft, if you are using the motor with a belt or lead screw, then you can turn it on and off if you are going to park it, but yeah, you have to know what you are doing. And then we have to define the proximity sensor pin as an input, so we will look at that wire whether it is high or low. And as I told it during the video, you have to make sure that the voltage that comes out from the potentiometer, which is now the regulated voltage, that should not be higher than 5 volts. So it should be somewhere between 3.3 and 5 volts, preferably closer to 3.3 volts, because that will be then considered as a high level, and that's what we want, whether it is high or low. And then the loop is super simple. So this is what I mentioned by the 4 lines. So technically we are just polling the pin. We are not doing anything else here, so we can afford it in terms of speed. So we are just reading the proximity sensor pin, and then we see if it is 0, then that means that we are on the ground. And that also means that something is close to the proximity sensor. And this trigger mechanism or trigger logic depends on the screw at the back of the proximity sensor that I showed you. So you have to turn that screw back and forth and see how you can reach your trigger distance between the specifications of the proximity sensor. So if something is close, then we set the speed in the positive direction, which is now it's a positive number in the set speed function, and then we just run the motor. Otherwise, we just go in the other direction by defining the speed to something negative. But we have the same speed, and as you could see, since this code runs like crazy quickly, it takes no time to change the direction of the motor when you trigger the proximity sensor, so it works very well. But I guess if you would start to add more and more code, you really have to know how to code it efficiently. So might be you might want to change this polling into an interrupt, for example, and so on and so on. But this is just the basic principles of using the proximity sensor. There is much more to them. They can be used for much more things that I showed you, but I just wanted to show you the very basic details, how you can use it and how you can wire it up with a microcontroller, with an Arduino based microcontroller, and how you can code it to at least make something move or modify the condition of something, or the status of something. So basically this was all. So I hope that this video was useful to you, and I hope you learned something, and see you in the next video.